Cooper, sorry I didn't record the last part. This is for you. Hi. Hope you're good. Wait, I think he has an appointment. Hope your appointment's good. Hi, Cooper. Everyone say hi, Cooper. Hi, Cooper. Okay, so here's the alternate form. So this is new. That was just a review from the video. This is actually the new part. So an alternate form starts off the same way. The first point, the x1, y1. Okay, same point. The alternate form says your x2 has an x coordinate of a, and if you plug a into the function, what is your y coordinate? F of a. Okay. All right, let's do our slope formula again. Same thing, y2 minus y1 over x2 minus x1. So slope is, what should I write? F of a minus f of x divided by okay, or we could do y1 minus y2 divided by x1 minus x2, right? They're interchangeable as long as you're consistent. You guys agree with that? Okay. Miss Rice, why are you writing it both ways? Because it's more traditionally written this way and I wrote the points backwards. This is the one that's typically used. Okay. So if we're going to compare this one to the video, this is going to be the slope between 2 points, okay? You have the distance between x and a. So how do we find the limit of this? What would we want the limit to be approaching if we want those distances to get closer and closer together? We don't have an h this time, so we're not going to say h is the distance and h is approaching 0. We have an x value, we have an a value. We want the distance between x and a to be getting closer and closer together. How do we make the distance between x and a to get closer and closer together? Yeah, we're going to say x is approaching a. Does that make sense? If the x value is approaching the a value, then they're going to get closer and closer together. Okay? If the x value is approaching the a value, then those 2 points are going to get closer and closer and closer together. Does that make sense? Okay? So if the a value is 5 and the x value is 4, and then it's 4.1, and then it's 4.2, and then it's 4.3, and then it's 4.9, and then it's 4.99, and then it's 4.999, and it's 4.999999999. As we get closer and closer to 5, those 2 points are going to get closer together, and then eventually we're going to be approximating that derivative or that slope at a single point. Does that make sense? Okay. So the way that we write this alternate form is we say the limit as x approaches a. F of x minus f of a, x minus a. This is an alternate form. It is not as common, but it is still used. So we have to know both of them. Okay? Now, if you have a color, if you have a pen of an alternate color, if you have a marker, if you have a gel pen, something like that, we're going to write this in the other color. Okay? This is a special note. I said this out loud, but we're going to write it down. Okay? The limit as x approaches a number of a function equals a y value. We learned that last unit. The limit as x approaches a number of a function is a y value. We learned that last unit. Okay? The limit as x approaches a number of f prime of x, this is the derivative notation, that's shorthand for derivative notation or slope notation, equals a slope value, or just a slope. Okay? that is this unit. So there's a difference between the outcome of a limit from last unit to this unit. Last unit, our outputs were y values. This unit, our outputs are slope values, okay? I will say that over and over and over again until it clicks. You might have an epiphany at some point. You'll be like, oh my gosh, they're slopes. And I'll be like, yes, I said that the first day, but it's okay. It's okay. You have that epiphany, and I will support you in your epiphany, okay? And then I'll be like, go look at that colored markings on your first page of notes. And you'll be like, no, 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 I had an epiphany. I'll be like, that's right. I support you, okay? All right, let's go and do an example of some of these problems, shall we? All right, example. Find the slope of the tangent line. What does tangent line mean? Yeah, hits the equation, or hits the curve. Hits the curve in 1 point and 1 point only. Find the slope of the tangent line of y equals x squared plus 1 at x equals -4. Okay. Now, whenever you are doing problems like this, you can always use either form of the derivative. We're going to do this problem twice. It's going to be annoying, but we're going to do it twice so I can show you how to use both forms. Okay? All right, here we go. So first, we're going to do the limit as h approaches 0 of f of x plus h minus f of x divided by h. So if we do that form, we're going to need to know what f of x plus h is, and we're going to need to know what f of x is. Okay? So we'll start with the easy one. What is f of x? X squared plus 1. Okay, that's the easy one. X squared plus 1. Okay, the one that is slightly harder, but not too bad, especially after the summer assignment, right? Especially after that. What is f of x plus h? Doesn't have anything to do with the -4. F of x plus h, what does that notation mean? X plus h squared plus 1. So it means take the function, plug in x plus h for the x, and then write the rest of the equation out. So f of x is just the function, f of x plus h is the function with the x replaced with an x plus h. Is that comfortable? We can do that? Okay. Now, we got to do a little bit of math here, a little bit of simplifying. So if we do the simplifying, do you guys want to do the simplifying in the problem? Or do you want to do it off to the side before we get started? Off to the side? Okay. So let's do it now. We're going to do x plus h, x plus h. There's x plus h squared with a plus 1 on the end. Okay. Now what do I do? FOIL it. X times x is, okay, x times h, xh, h times x, xh, h times h, and then plus 1. Whew, it's running out of room. Let's see, can I zoom in? Kind of. Make it bigger this way. Okay, kind of bigger. So I have x squared plus 2xh plus h squared plus 1. Are we comfortable with that? Okay. So now I'm going to go ahead and take f of x plus h, and I'm going to take f of x, and I'm going to plug them into the formula. We comfortable with that? Okay. So I'm going to write limit as h goes to 0, and I've got x squared plus 2xh plus h squared plus 1. There's my f of x plus h. I haven't done anything else. I've just written f of x plus h in the expanded form, the way that I just solved it all out. Okay, so I just wrote this part. Now what do I write? Yeah, minus f of x. Now I have to minus it and put it in parentheses because there are two terms, and I need to make sure I distribute that negative to both terms. So I have to put it in parentheses. Okay, since these are my notes, I'm going to do a very good job of showing my work. Why am I writing this limit notation off to the side? It's proper, and I don't want to kill an owl. All right, so I got x squared plus 2xh plus h squared plus 1. I'm going to distribute my negative minus x squared minus 1 over h. Okay? Now, what do you guys see? What cancels? The x squareds and the 1s. Okay? You can divide an h out. So limit as h goes to 0. I'm going to take an h out on the top, and I get 2x plus h. All right, do you feel how this is a little bit reminiscent of last unit? Just a little bit with like dividing something out and then still trying your direct substitution just a little bit? Yeah. Uh-huh.
You just like, put a slash through the denominator h and then the square of the h.
Yep. If you wanted to simplify as you go, that's totally fine. Nope. If you reduced your h's with this, then you would have done that all in one step, and the bottom would be gone. Nope. The bottom's going to have to go away. If you reduce, it's going to have to go away. Yeah. Good question. All right, so h over h makes a 1, so those are gone. So now we can plug the 0 in, right? The direct substitution at this point is going to work. Yes. Well, I factored out the h. Right, this h right here is what I factored it out. I took the GCF out. So I had 2xh plus h squared. So I took one h out from this and one h out from that. So if I do my direct substitution at this point, when I plug 0 in for h, what do I get? 2x plus 0, so I just get 2x. And at this point, I can say at x equals negative 4. And so now, if I'm saying at x equals negative 4, what do I get? 2 times negative 4 equals negative 8. You just know it's negative 8, yeah. Now, if we were to go through and graph this, x squared plus 1, make my window not quite so big. Actually, my window needed to be a little bit bigger. Let me make it a little bit bigger. So if I graph this, I'm going to go ahead and have, I'm going to see if my, so, no, it's not going to have the cursor go there. I don't know if I can make the cursor go to negative 4. Let me do this on Desmos instead. If I go to Desmos, I'm just going to default to Desmos because I know how to make the cursor show up here. x squared plus 1, if I go to x equals -4, right here. Okay, if you think about looking at that point right there, could you see how this intersection right there, if you were to draw a slanted line, would it make sense for the slope of that slanted line where those two cross to be a slope of -8? That's a pretty steep negative slope. That makes sense. That's a valid answer. Okay, we're going to do that exact same problem one more time. Okay, Ms. Rice, why? Because I want to show you the other method. Okay, I'm going to show you how you can do the same problem twice. All right, so we're going to do the other one. Because the two processes are slightly different, they each have their own purpose, and you might find that you gravitate towards one or the other, and it's fine to gravitate towards one or the other, okay? So the other one is limit as x goes to a of f of x minus f of a over x minus a, okay? So for this one, we want to have f of x and we want to have f of a. Okay, so again, f of x is what? X squared plus 1. Now f of a is f of -4. It's what you get when you plug in the -4, okay? So f of a is going to be f of -4. When we plug in the -4, what do we get? 17. Okay? All right, so what we're going to do is we're going to plug in all of the stuff that we have, all right? So we've got limit as x approaches -4. What is f of x? X squared plus 1 minus, what is f of a? 17 over x minus, what is our a value? Wait, what is our a value? -4. Okay. So the a value is the number you're trying to find the slope at. Let me go ahead and write that. A number you're trying to find the slope at. Okay, does that make sense? So let's simplify this a little bit. Do you guys see how the process is completely different? Yes, Ms. Rice, it looks completely different than last time. Marvelous. X squared. If I simplify this on the top, I get x squared minus 16. What do I get on the bottom? X plus 4. Okay, how am I going to do this problem? I'm going to factor the top. What type of factoring is it? Difference of squares. X plus 4, x minus 4. And then what happens? The x plus 4's cancel. At this point, you can do direct substitution. What do you get when you do direct substitution? -4 minus 4 equals -8. Same answer. Which one was less work? This one was clearly less work, okay? Now, we're going to learn more about these in the coming days. Each one has their purpose. Like I said, this one right here is less common. You're going to find out why, okay? You're not going to find out why today, but you're going to find out why, okay? So this one is less common, but as you can see for today's purposes, it's actually kind of nice. Finding the slope at a specific point, this one was a lot faster. Also a lot easier. It was not nearly as complicated as the other one, okay? So both of those are good options. They both get you to the right answer. One is a little bit more complicated. One is a little bit less complicated. We can see that the proofs behind them are both based on the slope, and they're both very similar. They're both valid ways of doing a problem, okay? All right, there's our notes. Let's go ahead and get started on the assignment.